Nice. 2-1. It's called set concepts. We've actually already dealt with sets a little bit. When I was talking about the real number system, I was breaking them into different sets. A set is a collection of elements. If you want a definition of what a set is, it's a collection of elements. And elements can be anything. They could be numbers, they could be letters, they could be dogs, they could be cats, they could be people, they could be you, they could be me, and they actually already are. When we set up a set, you start off with a squiggly. I call that a squiggly. It's actually called a brace. A bracket is the square one. A brace is the squiggly one. So it starts off with a brace, and when it starts off with a brace, this is read the set of. There's actually English attached to every symbol I write on this board. So if I write a symbol, you have to wonder what the English for it is. So the set of, and maybe 1, 3, 5, 7. All right. Now remember, a set is a collection of elements. So what is 1?
An element.
It's an element. I could care less if it counts for the value of 1. It is an element. It's a symbol that is inside of this set. 3 is also an element. 5 is an element, and 7 is an element. To state that mathematically, we would say 5 is an element of the set 1, 3, 5, 7. That's the mathematical language behind it. This is actually clarifying that 5 is part of the set. 5 is an element of the set. That symbol right there represents, is an element of the set. Abbreviated element. The little e is really read, and for most people, element. But for you, the best way to read it is an element of the set. If you keep it long, then if I write 5 is an element of the set 1, 3, 5, 7, then you would say that it is true. If I put 8 out here and said 8 is an element of the set, you would say false. It becomes obvious when you read it in English. If you look at it mathematically, it gets a little fuzzy. So if you read it in English, the answers are obvious. If you can't read it in English, you're going to be guessing. And I'd rather you not guess. Okay. The other thing about this writing, this is called roster form. When I take attendance on my roster. That's why it's called a roster, because it is the roster form of a set. So all of you are elements of my roster. And if you who did not hear your name called today, please don't leave because you were late and I haven't taken your attendance yet. So I have the set of, remember the squigglies are read the set of, so this is the set of Mary, George, and Sam. So it becomes a set of elements, and the elements are Mary, George, and Sam. Pretty easy, right? Then there is something called set builder. Now set builder notation comes in handy when you have a set like this. That is not a perfect roster form. It's more of a descriptive form. You kind of get an idea of what's going on. It starts off with 1, 2, 3, 4, and you have these ellipses here. Now the ellipses that we talked about last week were off to infinity. But these ellipses are just saying something's missing, and then we stop at 50. So the pattern stays the same. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way up to 50. But that's not pure roster form, because roster form technically lists out every single element in a set. You see them all. So because this is not a pure roster form, I'm going to kind of switch it over. Let's give it a designation. This is considered the set A. When you use a capital letter outside and you say it's equal to a set, it becomes the set of. The set of A here happens to be the numbers 1 on all the way up to 50. That's a bad way of saying that. That way we can change it over into set builder notation. Now the book and me do this a little different. I could care less which way you do it. You can do it the book way or you can do it my way, as long as it has the key parts in it. Mine start off with X, in this case, is described as this. Any guesses what a big N, what that means?
Numbers?
What kind of numbers?
Oh, numeric.
Numeric. All numbers are numeric. Think about the first set of numbers I taught you.
Real.
Before that, I taught you the first set of
Counting numbers.
counting numbers, also known as
Real.
natural. Natural. So when you see the big N here, this reads natural numbers. It's called a double bar N. It's the natural numbers. I would teach you the rest of them, but they get a little weird. Like this represents integers. Integers. But we don't need those. Natural numbers are good enough for us. Then we're going to put a little bar here. So far this reads, the set A is the set X is an element of the set of the natural numbers. So basically you can say X's are natural, if you want to shorten it. This little bar here reads such that. Such that. In other words, I'm going to give it a description afterwards. So I'm telling you they're natural numbers, but then I'm going to classify what kind of natural numbers I'm dealing with. There's a couple ways of doing this. There are the numbers from 1 to 50. You could say it in English if you wish. I'm not much for English. I'm shorthand. So it starts at 1. It ends at 50. And I'm talking about these X's being anywhere between 1 and 50. To say that mathematically, you do this. That reads, X is between 1 and 50 inclusively. See, the problem with the word between is you don't count the endpoints. If you're between the fence posts, are you on top of one of them? No, you're standing in between them, so you're not including the fence posts. By saying the word inclusively, you're including the fence posts. And in this case, the fence posts are 1 and 50 itself.
Can I read that again from point A? Starting at A.
The set A,
That's it.
the set A is the set of, remember the squiggly is red, the set of X's that are natural numbers, or X is an element of the natural numbers, such that X is between 1 and 50 inclusively. Or you could say, you could put it in words too.
Set of X.
It's a natural number and X is between 1 and 50. I prefer this way because it's shorter. It's condensed. I don't say X too many times, but this is the way the book does it. I don't care which way you do it. All right, let's talk about well-defined. We are only going to be dealing with well-defined sets. So I'm going to write 2 sets up here, and you tell me which one is well-defined.
Pretty much what it's on good, written all the way out.
Well, let's see. B is equal to the set of X's that are animals, such that X is a dog. Dyslexia getting to me again. Okay. And then set C is the set of X is an element of the solar system such that X is a planet. Now, if you're talking about the solar system, you're talking about anything that goes around the sun, anything that has an orbit with sun as its focus. Or you could think of it as its center, but it actually is its focus. Now, one of these sets is well-defined, the other one is not. Is well-defined?
No.
It's the animal.
The animal one is fine, because when I say we're talking about an animal, such that we're talking about a dog, you all know exactly what I'm talking about. Furry usually has a tail that's wagging and or trying to bite you. One of the two. The other one, though, X is part of the solar system such that X is a planet, has become kind of vague lately. For instance, some people still think Pluto is a planet, but it's not now. And then there's this other thing that's further out that is considered a planet, but it's smaller than Pluto, so some people think of it as an asteroid and some people think of it as a planet. So the second one is more, which theory do you subscribe to? So if you ask any person on the planet Earth what a planet is, you're going to get different answers. But if you ask a person what a dog is, you're going to get a dog, a German Shepherd, mutt, everybody pretty much knows what a dog is. Another idea that could go with this is X is an actor such that the actor is good looking. Now, certain people think certain features are good looking, and then that becomes an opinion. Anytime you talk about a set as an opinion, it is definitely not well defined because it changes for different people. When we talk about a set being well defined, it's true for everybody. Even space aliens would agree with us.
So B is the only well-defined set.
B is the only one well defined. So this one is well defined. This one is not. Because Pluto is a planet or is not a planet depending on who you talk to. They keep changing things. Science always changes the way they think of things. Mathematicians are a little bit more precise. We like dealing with absolutes. Alright, so that's set builder and well-defined. Equal sets. I don't know why this confuses people, but it does. There's a better way to define this later on, but for our purposes, equal sets have exactly the same elements. You would think this would be an easy concept, but people, for some reason, they start thinking about it and weird things happen. So if I have set A is the set of 1, 3, 5, 7, and set B is the set of natural numbers such that X is odd and that. Yeah, what?
Yes.
The first one's easy. The set A is the set of the elements 1, 3, 5, and 7. That's simple. Set B over here, though, is the set of natural numbers. You want to really abbreviate. B is the set of natural numbers such that the numbers are and between 1 and 7 inclusively. Starts at 1 and ends at 7. My suggestion, when 1 is given to you in set builder notation, change it into roster form. Change it right into roster form. Then it becomes kind of obvious what the answer is. So what are the odd numbers between 1 and 7 inclusively? 1, 3, 5, and 7. This is identical to this. They are equal. So we can say that A is equal to B because there's actually two things going on. They have the same number of elements, both of them have 4, and they have the exact same elements, 1, 3, 5, and 7. All right. Everybody understands that, right?
Hold on. Not really. Don't go too fast.
You think this is fast? Woo.
We can't see.
Oh, I know, I'm in the way. I have to put my body someplace. X is a natural number such that let me change that to make that 1. Are C and D equal?
No. No, that's one. Wait a minute. Yes, it is.
Be careful now. I've changed
Because
things.
you don't have the line equal.
The little line under the inequalities are equal to.
Okay.
Without the little line, they become not equal to. So this is definitely not equal to 1, and it is definitely not equal to 5. So what numbers am I talking about is strictly between 1 and 5, which are
2, 3, and 4.
2, 3, and 4. Are these two sets equal?
Yes.
They're identical. So we can say that C is equal to D, without a doubt. So be really careful. If it's missing those little equals, the words become between. No fence posts anymore. We're not talking about the outside pieces. So this one is strictly 2, 3, 4, where this one, because of the equals, it starts at 1 and ends at 7. Okay. One last one for equal. How about, let me go back to A. This is a different A. A is equal to 2, 4, 6. B is equal to natural numbers such that X is even and 1 is less than or equal to X is less than or equal to 8. Now, before you answer the question, are they equal? I highly suggest you figure out what the heck we're talking about in the second set. What is the first element of the second set in roster form?
2.
2. Because this one says it starts at 1, but the first one says it is even. So 1 is not even, so the next number is even as 2. And then, and then, and then. Now, 2, 4, 6 is in A, and it is also in B, but are they equal?
No.
No, because this one has an extra element. It has 4 elements where the first one only has
3.
They can't be equal if they have different numbers of elements. So we're going to say here that A is not equal to B. There is a relationship between them. It's just that they're not equal. Okay. Sound good?
Yes.
I guess. Out of those, you should get an idea of what it means to be equal and what it means not to be. You should, I hope. I pray. Go for it.
That X means it's between 1 and 8, right?
Where are we? Here? Yeah, this is between 1 and 8 inclusively. Inclusively because of the equals. So it starts at 1 and it ends at 8. But then this word up here says it has to be even. So you're picking the even numbers from 1 to 8, which are 2, 4, 6, and 8. Okay. All right, let's talk about the next word, which is equivalent. Now, your teachers up to this point pretty much interchange equivalent and equals. They pretty much mean the same thing, but for sets, they really mean 2 separate things. When we talk about equivalent, we have to also talk about something called the cardinal number. Cardinal number. The cardinal number of a set is just how many elements are there. So this just answers one question. How many elements in set? Let's call it A for the fun part of it. Now, mathematicians are lazy. Mathematicians do not like writing English because most of them do not know how to spell. including me. So when you see something like how many elements are in set of A, mathematicians don't want to write all that wording. So they kind of abbreviate it down to this. And it reads exactly the same way. A little n in front of a set is going to read how many elements are in set A. And then you just answer it. So for instance, how many elements are in the set of 1, 3, 5, 7? 4. So when you go NA here, the answer would just be 4. Now 4 is not an element, it is just how many are there. That's all it's asking. How many are there? Now, if we're talking about equivalent sets, then we're just saying that two sets have the same cardinal number. They just have the same number of elements. Now, are equal sets equivalent?
No.
Yes. If you're equal, you have the same number of elements, and therefore they are equivalent. Are equivalent sets equal?
Yes. No.
Not necessarily. Don't say yes or no, but it's definitely not necessarily. They could be, but they don't have to be. They're not forced to be. For instance, if I have set C is equal to 2, 3, 4, and set D is equal to little a, little b, little c, are these two sets equal?
No.
Heck no, because 1 is definitely not A, and 2 is definitely not B, and so forth and so on. Are they equivalent?
Yes.
Yes. Because the cardinal number of C is 3, and the cardinal, gotta say this right, cardinal number of D is also 3. So we're going to say that C is equivalent to D. Notice how I wrote equivalent. 3 lines. Equals has 2 parallel lines. Equivalent has 3 parallel lines. Another shortcut because we don't want to write the word equivalent. Mathematicians are lazy. You'll get used to that. Whenever we can write things, a whole sentence as a symbol, we do it all the time. Okay, so that's equal and equivalent and cardinal number. That leaves the hard part. I don't know why this is hard.
Oh, Jesus.
But people get confused between these two. The first thing you should know about these two sets is that they are exactly the same. They're identical. They mean exactly the same thing. They have the same number of elements and the exact same element. All right? Now, how to describe this? The set of NBA basketball players shorter than 4 feet.
None.
There are none. So I still have to write a set about them. So I'm going to start off over here. The set of, who do I put in it?
NBA basketball player.
Of under 4-foot basketball player. What name do I put here? Zero? Zero's a name. I renamed Zero. I think I'm going to rename myself as Mr. Zero. But you can't put anything in there because there is nothing in there. So you just put absolutely nothing.
So that is
Thus the name empty set. There's nobody in there. Not even a symbol. No symbols whatsoever. You put a 0 in there and all of a sudden you put in one element. Then there is one thing that is under 4 foot in the NBA, and we know that don't exist. So, when you're talking about the empty set, is the set of emptiness. There's nothing in there. It's a void. Now, the null set, which is exactly the same as the empty set, is written this way. It's like the no smoking sign. There's not even a 0, is the way I think of that symbol. You have 0, and then you don't even write it. There's nothing. Absolutely nothing. And these two sets are equal. You have a choice. If you see this symbol and you don't like working with this symbol, replace it with this one. If you see this symbol and you don't like working with it, replace it with this one. They're interchangeable, in other words. Most people don't like this one and switch it over to the empty set because they like seeing the brackets and absolutely nothing in there, where this one is kind of fuzzy. This one's popular for in algebra. You do your little work and there's no solution, and you write this. This is the solution of. There's none. There is none. It makes sense in algebra. So the null set and empty set, identical. One last type of set. We have a problem. If I have the set of A is equal to 2, 3, 4. Cardinal number? 3. Has 3 elements. My problem is this. Sometimes you want to talk about what's in a set, but the other thing you want to talk about is what is not in the set. Now, if I say what is not in the set here, wow, this gets kind of confusing. Well, it could be 1, 5, 6, 7, 8, off 2, infinity. It could be -1, -2, -3, integers. I didn't specify what kind of numbers we were talking about here, but it also could be George, Jack, Jill, a piece of sand, the book on the table, the planet Earth, the planet Mars, the sun, all of the other suns of the, how many things are out there? Way too much to talk about. So what we're going to want to do is kind of constrain our argument to a more finite space. And to create a finite space, we're going to define universe. A universal set, or also known as the universe. We're going to create our own universe. So we know everything that's inside our universe, so we can talk about what's in it all the time. For instance, if I say my universe is equal to, and universe is always going to be capital U. You do not use capital U unless you're talking about the universe. All right. So my universal set is going to be the natural numbers. Natural numbers are nice because there's nothing in between them. If I made them real numbers between 1 and 2, how many numbers are there? An infinite number, and I don't want to talk about that. So when we talk about natural numbers, it just makes things nice. So my universe starts at 1, ends at 10. So we're talking about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's it. That's my universe. Now, my universe becomes my maximum number of elements I can talk about. I can only talk about 10 of them. No more, no less. My universe has 10. And if I tell you that A has my 2, 3, 4 in it, then what elements are not in A? I can answer now. It's not that hard. What elements are not in A? Well, that would be 1,
12, 13.
5, 6, 7, 8, 9, and 10. It becomes an easy thing to answer. All right. There's a name for this. Remember, mathematicians don't like writing English, so they're not going to sit here and go, what elements are not in A? They're going to write A, put a little dash next to it. So when you see a set with a dash next to it, it is what is not in A. What is not in A. This is called a complement. This is called a complement. Not the complement like you have nice hair, your eyes are beautiful. This is a complement of a set. So a complement of a set is what is not in it. What is the opposite of it, if you want to think of it that way. So when I talk about A, I'm talking about 2, 3, 4. When I'm talking about A's complement, I'm talking about all the other elements that are not in A, which are not 2, 3, and 4. So they become 1, 5, 6, 7, 8, 9. The complement of A. So that little dash actually has a name. It's called the complement. The complement. Yay! That's 12-1. 12-2-1. That's it for 2-1. Get a breath. 2-2. Now, I haven't done anything mathematical. Pretty much what I'm doing right now is language. This is language skills. I'm showing you symbols and I'm telling you how to read them. I'm showing you definitions and telling you what they mean. Now you need to take all of that and start doing more definitions. 2-2 is just more. When we get to 2-3, we start doing mathematical operations and stuff like that. So, before I get there, I have some questions for you. These are true, false. These are the ones I worry about on the test. Your assignment is going to be all true falses in any of these sections. I want you to know them inside and out, and then some other ones that I come up with. These are the ones I come up with. Number 1, don't shout out the answer. But this is what I'm going to say in the test.
Are these what, like examples?
Yeah, this is an example. I'll say true or false. Be careful. The rest of the directions are, if it is false, explain why. I don't want you just guessing. I don't want you writing true, and I don't want you writing false. I want you to say why it's false. Take a guess. Most of my questions are false because I want you to explain them. If they're true, put true and move on to the next one. But if they're false, you have to sit there and tell me why, because that's actually more important than just saying that they are true or false. So, number 1 here, true or false? Why?
D is not an element of the set of A,
D's
B,
not
C.
over here. See, this is saying D is an element of the set, but D isn't even over here
set.
to be an element. So, false because D is not in set. It is not part of the set. It is not one of the elements of the set. Hey, these are easy.
No.
No? Oh, they're easy. If you read them right, they're actually extremely easy. True or false? Why?
Apples are not a vegetable.
They're not?
No.
Oh, darn it. I eat them as vegetables all the time. Oh, well, it's false. Apples are a fruit, not a vegetable. What are tomatoes? Is that a fruit? Or is it a vegetable? It's one of those cross the bridge type ones. Eat them and you get both of them. Do you know they used to think tomatoes were poisonous?
What?
Tomatoes, people wouldn't eat them because they thought they were poisonous. Isn't that weird? Oh well.
People were
3. This was long time ago.
Oh, okay.
Number 3.
It's false because 5 in the set by itself.
It's true.
Five
Okay,
is-
how about this? True, hands up. About half the class. False, hands up. About less than half the class. So some people didn't even put their hand up. Okay. If you read this
I
in
didn't know
English,
that.
if you read this in English, the answer becomes obvious. The set of 5. This reads the set of 5 because there's a squiggly in front of it. The set of 5 is an element of the set 1, 2, 3, 4, 5.
True.
False.
Oh.
Because when I get to this 5, I call it 5. When I'm over here, this is called the set of 5. See up here, this is just D, and this is, well, if D was in here, it would also be D, not the set of D. So this one is false because the set of 5 is not in here. It has to be identical. So this one is false because the set of 5
is not in that set.
is not 5.
False.
The set of 5 is not the element 5. They are different. They are different. To make that a true statement, I'd have to put squigglies around my 5. So it would be 1, 2, 3, 4, squiggly
Squiggly.
5. It has to be identical. No, I can't change it. It's false. This is a false statement. I'm not going to change it. I guess similarly, we could ask this.
Would there be a problem like that? Where there actually is a set inside of a set? Yeah, that's what I was thinking. Before I ask,
Up here?
yes, is there any way that there will be a set inside of another?
Oh, yeah, why not?
Okay.
Think of it this way. This is a class, I have a roster for this class. If you take the roster of all the classes and put them together, that becomes the set of the rosters of the school. But each one of the rosters is a set on its Oh, and so you have sets of sets.
I
That's
got a
perfectly fine.
question.
Yep.
Is that a square or rectangle?
You tell me.
It's a rectangle.
That's a square.
This is supposed to be a square,
And that's a rectangle.
and that's a rectangle. Therefore, this is
Not equal.
That's
false.
false.
This shape is not exactly the same as this shape. They have some shared things, four sides and 4 right angles, but one is a rectangle with 2 longer sides, and the other one is a square where all 4 are equal. So this one is false. Even though they share some similarities, just like this one up here, they're not identical. They have to be identical. False, because a square
It's not a rectangle.
is not exactly what I drew on the other side, a rectangle. Oh, by the way, a square is a rectangle?
Excuse me?
Oh, we won't get into that.
Oh,
But in this case, they have to be perfect. They have to be perfect. Can I put a true one up here? Many times.
Yes.
You want me to put a true one up here? No, all right. Let me see if I can find a true one in my paper. Is this one true? Yeah. All right, this one. 5. No, could draw, right?
That's a question mark.
Hold on, mine don't look like that. I know what you're talking about.
You can put the words in there if you want. Wow, I wrote that really big. This set, whatever it is equivalent to this set.
1, 2, 3, 4.
What's the hold up?
And that's supposed to be true.
It's true.
Now, what is equivalent looking for?
It's
The cardinal number.
The number of elements. Now, the number of elements over here is
4.
the, suits of a deck of cards. Over here, we're talking about the natural numbers less than 5, which would be 1, 2, 3, and
4.
strictly less than 5, so 5 is not part of it. How many elements are over here?
4.
4. And because they're exactly the same number of elements, they are? This is true. True is usually easy because it pops out as the definition, or it reads perfectly in English. If it doesn't read perfectly in English, or it doesn't pop right out, more than likely it's false. I'm not saying it's guaranteed false. I'm just saying I would lean a little bit closer to the false. True usually just goes, it's true. Now, the only reason you would get confused with this one is if you got confused between equivalent and equal, and you don't know your definitions well. That's something different. That'll mess you up, and you'll say false because you're thinking they're equal. They have to be exactly the same. But in equivalent, they don't have to be.